Thanks for joining me. I wanted to do another video demonstration of some Python code in the network. This particular video is not going to be hands-on. It's not going to be a, well, let me not say that. It's not going to be a live coding video. This is more going to just walk through the implementation of a lab that I'm actually putting together for a course that I'm working on. But essentially, it'll be doing some network automation, but within like service provider MPLS networks. All right. Before we get into it, I'll just go over the architecture. And this architecture is actually built in EVE-NG, but this is what the logical looks like. So you see, we have our NOC here. This is essentially our network operations center, and we have the two core routers, which is essentially the NOC core routers, but they are also PE routers within the MPLS network for the L3 VPN services. And I'll get into that once we get the whole architecture kind of laid out. Now, as far as these devices are concerned, this is my core network. So those are my core routers. So essentially, this will be my P routers in the MPLS architecture, and then we have our PE routers here. As you notice, we have color coordination going to our physical links. So 100 megs is the green links, 75 megs is our red links, and then yellow links are 50 megs. So each site, each PE essentially has a primary path out to its respective core, and then as from a failover scenario, it can fail over to the additional link with less capacity, but it has the ability to fail over and route traffic that way. So that's kind of the design here. Now, in this lab today, I'm going to show you guys a script that I wrote that it actually talks to the network, validates the link health, and then sends the user a message. And then you can actually have it do more things, but I'm going to just keep it simple for this example. But like I said, the NMS system will launch the Python script, and that Python script will go through all the devices in the network and essentially check its link health by looking at the IPSLA configuration. So I'm going to show you guys what that looks like next. So the way we're going to be actually interacting, the data that we're going to be pulling from the devices is going to be the IPSLA statistic information. And this is what the SLA strategy looks like. So essentially, we have our PE routers that has an IPSLA configured, and it's going to be operating in VRF management. Like I said, within the L3 VPN network, these routers are actually PE routers, and that's because on each of these PE routers, they have a VRF called management provision, and then from there they all have a loopback address that's provisioned in that VRF, so that way the NMS that is also a part of the VRF management can communicate with these devices through the core without actually having to route natively in the core, if that makes sense. So you're tunneling through the core to get to the PE routers rather than natively routing in the core. Okay, now like I said, this is the UDP jitter strategy. So we have a IPSLA responder that's set up on the router here, or in the NOC. And in this scenario, our SLA responders are going to be R3 and R2. No, actually, I'm sorry. It's actually going to be my core switch. That's right. So in this scenario, it's actually the core switch. So the IPSLA responder is actually provisioned on the core switch. And then what'll happen is it'll come back and send the measurement, so that it'll respond back, and then PE router would take that packet and do whatever measurement that it needs to determine the link of the health of the uplink that it's connected to. Now, before we get into code, let's go ahead and look at the sequencing of the application. So this particular service is going to be called my link monitor service, and essentially this is what it looks like from a communication standpoint. So in the sequence diagram here, you see that the link monitor service, it's going to go and get the IPSLA statistics. The asset will return that data back, and then it'll get the Ceph next hop, and that's going to be for the SLA responder destination. So what I mean by that is, let's go back to this diagram, is that in this step here, what I'm actually asking the router to do is saying, hey, based off of, I want you to tell me what your physical interface is and the next hop is when you recursively look up the route to get to this router here. And that's how it's going to actually determine what the active exit interface is on the device. Instead of having just to look at the routing table, I could just look at the ceph table, and then the ceph table will give me back the interface as well as the next hop. And so I'm extracting that with the application. And then it has some internal stuff that it does there, and then it'll actually um, log a message to the user. So let's see what that looks like here. So starting here, this bubble here represents this initial communication where we're going and getting the statistics, and then we're also getting the ceph and next hop. And then from there, we're gonna extract the round trip time and the threshold threshold over percentage from the SLA statistics. So we're extracting information from this data here, and then we're going to extract the next hop and physical interface from the IPsef show output, and that's going to be extracting the data from here. And then the next step, we're going to check if the the RTT is over 20, and that's going to be 20 milliseconds, I believe. Yeah, I believe it's 20 milliseconds. And then if it is over, then we're going to log this error. And this could actually be whatever. I could set up another trigger to where it does a build step, it shuts the interface down, but in this example, we're just going to keep it simple. And if it's not, then it's just going to go back and loop through each of these devices and then essentially run this logic. Now you guys have an idea what it looks like visually. Let's see what it looks like in the code. So this is the code. This is the file here that we're going to be using. It's called SLAmon, and as you can see in the description, we just said the same thing. Gets the IP SLA stats on SLA98, which is the SLA number that's provisioned on the device. Gets the next hop and interface ID of the active core facing interfaces. Validates if the SLA jitter is within acceptable limits, and then logs message if jitter is over the threshold. Now we'll go ahead and just jump down into the main function, and then essentially I'll show you guys how this is working. So we're going to go ahead and do an infinite loop, and then we're going to say for host and get host. Now you see this function here. This is what we call a generator function. Now instead of me just having a list or something like that actively on the file system, or instead of me having a list that's sitting in memory in the application, I can actually actively open the I can actively open that open a file and then return load the contents from that file and then return each host from that file. But it's in a generator format, so it only takes up as much memory as it needs, which means it'll be one host at a time. So even though you're in a for loop, it's like the loop pauses and then waits until you're ready to get the next item, and then it'll grab the next item until the iteration is over. So that's what this function is doing. So I'm using an iterator opposed to returning a list. And if we go into that, or I'm sorry, we're using a generator function instead of returning a list, and we'll show you. So going through, we'll have a logging message that says loading DB, and then you see we have the open of the host file. And so this host file is actually going to be this file located on the file system. It's going to be host called JSON. So this is my way that I like to do like easy databases, if you will, for quick projects like this. Just because I can store the JSON, I can store it in the JSON format, and then if I have different hosts in different environments, I can specify that within the data structure and not have to do any changes to the major code. So that's kind of the benefit there on why I do that. So essentially it's just acting like a makeshift database. As you can see, it's opening that file, it's loading the JSON data, and then I'm grabbing that lab host key, which is essentially these hosts here, and then we're going to say db updated, and then from there we're going to take that lab host list and we're going to iterate over it, and then we're going to say for let's see, for host and host logger.info providing host, and then we're just going to yield and say, okay, when you're ready, I'll give you the next item. Now we're going to say once that's done, we'll go ahead and sleep for half a second, and then from there we're going to say connecting to host. Now we're going to do get IP SLA stats. Now let's see what this function is doing. Now what I'm doing to actually connect to the devices, I didn't talk about the imports, but we're actually going to be using NetMiko, just because it's just super easy. And here we're going to set up our data structure. Essentially, that'll be representing our NetMiko connection. And then from there, we're going to do a context manager, and then we're going to say connection handler, pass that data from the data structure. Here's our connect handler. And then the first thing we're going to do is we're going to send a command, and we're going to do the show IP SLA statistics. Now, once that output comes back, we'll do another command right behind it, and we'll do a show IPsec VRF management, and then the IP address of the actual SLA responder. That's the responder IP, and it'll get that output. And then from there, we're going to parse the jitter threshold. So let's see what that looks like with this function. So essentially, we're going to do a regex match on that, and then grab the threshold data, and then from there, the threshold will extract the over threshold, and then the round trip time, and I'll show you what that is. So if I go to router 7, show IP SLA statistics. Essentially, the numbers that we're grabbing with the regex is we're going to grab this percentage here, which is the over threshold percentage, and then we're going to grab the round trip time. I believe that's the two that we're grabbing. Yep. Yeah, we're grabbing these two numbers here. And then we'll return that into this dictionary. And then from there, let's see what the next command would be. We're going to parse the Ceph next hop. And so what we're going to do is, let's see what that command looks like in the router. As you can see, we have this here, show IP Ceph, and it gives me the physical interface as well as the next hop IP address. So it's going to grab those two pieces of information for me and then return that back in a dictionary as well. So let's see what that looks like. Parse IP Ceph, and you see it'll say next hop and link, which will be the physical. And I don't know why I did this way. I actually want to fix that, but that'll be later. Okay, so from there, since now we have the normalized data, we're going to go ahead and do that round trip check. So we're going to say if jitter data.get round trip time is over the configured threshold, and if we scroll up here, our threshold is 20. Let's go back down. And then we're going to say log error, and we're going to say the management IP address on uplink blank is over threshold, and it's going to put its over threshold percentage, how much over the threshold it is. And then essentially once that's done, it will log the output of that response and then move to the next item. So like I said, it's pretty straightforward. And let's go ahead. Okay. Now, the way I'm doing the development on this is I'm actually running GitHub, or I'm using Git, and then I'm actually pushing the code over to my server in my EVNG environment. So that whole network that I showed you guys earlier, that's all actually developed and built in EVNG. And essentially, my Eve can go out to the internet through the public internet. This is essentially acting as a NAT router, so we can route out here to get out to the internet. And then from here, we have the bits NMS that's operating in the network. And let me show you guys the VRF that I was talking about earlier, just so we can validate that that's there. So show IP route VRF management, and as you can see, we have the management VRF up, and that's going across the MPLS core. And we can go to switch knock 1, or knock the switch here, and then we can just do a show IP route to show you that we're not, this is the global table of the core switch, and if I do a 1099.70, that's the actual IP address of this PE router here. So we got connectivity through the MPLS core over to this router, and we know that that's working. So let's see the script. Let's see how the script works. So in this server here, we're gonna go ahead and go to so actually I wrote a little script that will actually do a bash run for me. So knock a, where is cat run SLA mon? And as you can see, it's very simple. All I'm doing is doing a Python run. I'm going to run that Python script. I'm actually going to output the output to this text file and then essentially run it as a background task. So let's see what that looks like. Cool. So if I do a cat output.text, as of right now, you see that we're actually not getting any data back. But that's because I have clean links. But let's have some fun, because this is the cool part that I like about the automation stuff. And I'll tell you how I know this is working. We'll go to router 7, and as I go through my logs, I should see a connect message coming in from the server here shortly. Give it a second. If everything is working as planned, it should be going here now, because it's actually cycling through the devices. And I'm not doing any threading, so it's going in a very linear fashion. So unfortunately, it's probably a little slow, but let's see. Let's see. Okay, there we go. So there we go. So this is the actual NMS logging in, and then you can see it exit once it's finished doing its commands and moving on to the next device. So we know that that's working. So it's actually going through right now and looping through each device. So let's have some fun. So we're going to go back to the NMS and let's check if my stats are the same. Let's see if I got any output. We still got no output. All right. But I know it's working because we just validated that the connections are going onto the device. So let's go and make the link a little dirty on CSR7. Let's go ahead and edit link quality. This is one of the cool features that I like about EvenG, is that I can do this. So we should see some instant failures start to happen. Apply and save. So the link between these two are actually going to have some quality issues, and that should actually raise up my packet loss, which essentially should now trigger my threshold for my IP SLA that's running. So if I go back here, let's see if we have any output. Because it's cycling through the devices, it might take a second for it to pull the output out. And again, this lab isn't supposed to be like a real-time configuration, because there's other methods of doing that for reactive provisioning, and I would have made it a lot faster with threads, but I'm gonna let it go through its thing here, because it's actually still logging into the devices. I didn't know where in that loop it is, so let's see. Let's go back here and let's make sure that show IP SLA statistics, and let's see if we're going over our threshold yet. Oh, that's interesting. Why am I not? Let's see if this is working. Let's make sure this is working. Oh, you know what? Let's make sure that I'm actually show IP Ceph. Yeah. Okay, let's see. I think we have a bug here on the SLA, because that should actually be kicking up. Let's restart it, because that should actually be run section IP SLA. The beauties of working with virtual platforms. So SLA statistics. Let's see if that works, because it should be sending our samples. Let's see. Okay, there it goes. I don't know why that was bugging out. Okay, that's super weird. Alright, so actually I should start seeing it now in the output of the NMS. So let's see. Let's give it a second. It's going to go through its rounds. And we'll know here. So it just logged into CSR7. it's going to log out of CSR7. And then, bam. Okay, perfect. So now you can see that it tells me that I'm having issues on uplink gigabit 1 over threshold 62%. And now when I go back here, let's see if it's still the same case. So we're at 64%. Let's see if the next time it goes around, it's going to catch that additional packet loss. It should catch it, but let's see if it does. Now I kind of regret not writing it because it's taking a little faster than I would like it to, but it is what it is. We'll probably do another video where I can turn this into a threaded application, because this is annoying. Okay, there we go. Yep, so now it caught it at 64%. So let's go ahead and clean the link up. Let's just say that maybe the fiber cut or whatever the case was fixed. Whatever was causing the intermittent loss, let's go ahead and apply and save. And then I should actually see on the CSR7 router that start to go down. Those losses start to go down. Let's see, make sure it's working correctly, hopefully. It's still going. Give it a second. I can't remember. So now, yeah, so now the frequency's back. So because now I cleaned the link up, we should be going back down to 0. And essentially we should get no more updates letting me know that link 0 is bad. Or link 1 is bad. So actually I want to try something now. So let's go ahead and do this. Let's go ahead on gig 2, let's edit quality, and we'll say 500 milliseconds here, 500 milliseconds here. We'll apply and save. And let's have us a failure scenario. So technically, if my SLA still works, I should I'm going to shut down my main link on gig 1 and between CSR 4 and 7. I'm going to shut down these links, and then I'm going to see if the SLA should actually start detecting that packet loss once the convergence happens, and if we should start seeing the new updated interface in our logs. So let's make that happen. So interface gig, and that's gig 1, and we're gonna shut that down. And then on gig interface gig, let's say 3, and we're gonna shut that down. So he shut down as well. Now if we go back to 7, show IP SLA statistics, let's see if our SLA is gonna fail us. Oh, dang. Okay, perfect. It worked. Okay, so now you see it immediately saw that extra packet loss because we're on that dirty link. And give it a second. Now it's got to iterate through the device and log into router 7 to figure out, oh snap, there's a problem. So just waiting on 7 to get its update. There it goes. And now you see it's updated to be gig 02. And so it's actively going in and grabbing the device. Now, I know this example was a little drawn out, and it may seem like this is like slow, but imagine in a production network where you're getting this type of latency, and it might be at a couple minutes at a time. And you know, if you're working and operating a major service provider network, your customers will feel it. They might not know what's going on, but they'll feel it. And you may not know what's going on because traffic looks like it's normal. And so this type of scenario where I'm constantly having the device polling and validating the quality of the links, I can kind of get ahead of traffic patterns or getting an understanding of, oh, okay, I see that I might be experiencing this higher than normal jitter times. You know, what's happening on this link? And you're not having to pay an engineer to do it. I mean, essentially, you're just doing it yourself and having the script go in and report. Now, in that logic, right now, if I go back to the actual script itself, in that logic where I hit this check, I could have done anything here. I could have done another step where I'm actually maybe shutting the interface down, setting an email, setting up a ticket to maybe the carrier, the upstream carrier device, or carrier who owns that circuit. The possibilities are endless. So yeah, just wanted to show you guys how you can do some reactive monitoring on your network devices using some pretty basic network automation. All right, thanks again. Talk to you guys later.